For the past 2 years, enterprise AI operated like a highly capable digital assistant. These systems drafted emails, wrote code, and summarized meetings, but the machinery always had to pause and wait for a human hand to push the work forward. They operated on a strict request and response loop. You typed a prompt, the machine generated an output, and then it stopped completely. A person had to read the draft, edit the errors, and click send before asking the system to do anything else. On top of that, every time you opened a new chat window, the system's memory wiped clean. It was a stateless architecture, meaning it retained no ongoing awareness of the larger project you were working on. The artificial intelligence was fast, but the person sitting at the keyboard remained the absolute limit on how much could actually get done. True automation was impossible as long as a human was required at every step. Now the architecture is changing. We are moving from tools that assist human thinking to systems that execute decisions on their own. Instead of giving an AI a single instruction, you give it a final objective, and it carries out a multi-step mission across various applications without waiting for permission. This is the OODA loop: observe, orient, decide, and act. The system perceives, plans, and executes autonomously. This architecture targets a massive $47 billion market by 2030. Yet the reality is severe. 9 out of 10 enterprise AI pilots completely fail to scale. The models themselves are highly capable. The block preventing them from working is the plumbing underneath. The information companies are trying to feed these systems is structurally incompatible with how machines operate. For the past decade, businesses organize their information for human eyes. That specific design choice is exactly what breaks an autonomous machine. A person can look at a dense spreadsheet, ignore the blank rows, and use their intuition to understand what an abbreviated column header means. We use visual layout and context to automatically fill in the gaps. The first wave of AI search tools operated on that same logic. Systems using retrieval augmented generation, or RAG, simply located relevant documents and presented them to a human, who then made the final judgment call. RAG is a technique where an AI model pulls information from an external database to improve the accuracy of its responses. This split screen shows the exact difference between human and machine logic. On the left is what we read, on the right is what an agent needs. To extract logic without visual cues, an agent requires purely programmatic, hierarchical structures and data endpoints. When an autonomous system attempts to navigate a human-formatted dashboard, it misinterprets the fields. Because it acts without human review, it takes those misinterpretations and executes real-world transactions based entirely on broken context. To bridge that gap, infrastructure needs to meet 4 strict requirements. The first is Application Programming Interfaces, or APIs. APIs are sets of rules that allow different software applications to communicate with each other. Agents cannot read PDFs on a shared drive. They need direct, programmatic pathways to retrieve and update records. This illustrates the second requirement, semantic context. When an agent sees an isolated node, like Q3 Rev, it doesn't intuitively know it means third quarter revenue. It requires a web of explicit metadata attached to it, tags defining the mathematical relationships and business rules governing that number. The third requirement is real-time freshness. If a system quotes prices using an outdated database, it generates compounding errors before anyone notices. This necessitates the fourth requirement, a circuit breaker. Automated programs monitor data flow and instantly halt processes when anomalies are detected. Tying this all together is the Model Context Protocol, or MCP. MCP is an emerging open standard that provides a universal way for AI models to securely discover and connect to external data sources. If a business lacks those direct entry points, precise definitions, real-time updates, and safety checks, its information simply does not exist to the systems trying to do the work. We can measure the stakes of this transition using an autonomy ladder. Software is climbing from strict rule-based sequences up to systems that adapt and act entirely on their own. At level 2 autonomy, the machine dynamically determines the sequence of actions, but a human remains in the loop to approve exceptions. Because a person is checking the work, the system can survive slight delays or vague instructions. But this chart shows what happens as we reach level 4. At this stage, the machine sets its own goals and executes financial transactions independently. As the autonomy level rises, the tolerance for bad data drops to 0. Granting a machine more independence removes the human safety net. Every step up that ladder places exponentially harder demands on the precision of the underlying architecture. As this aerial view illustrates, the business landscape is cracking and drifting apart into two distinct camps. On one side are organizations treating these new tools as a simple software upgrade. On the other are those completely rebuilding their foundational architecture. The intelligence itself is no longer special. The major tech companies are making their models and coordination software universally available to anyone willing to pay a subscription fee. A pristine, machine-readable environment is the only competitive advantage that remains. The deciding factor for the next decade of business is a single question. When the machines arrive to do the work, will your data be ready to feed them?